Hi everyone, today we're going to be having a quick look at radians, what they are and how to convert between degrees and radians. Now with maths methods in VCE, we tend not to use degrees for things, we use radians, and the reason for that is because the 360 degrees in a circle actually doesn't have a lot of mathematical meaning. Someone just decided we had 360 degrees. Whereas radians really brings together the ratio between pi and the circumference of the circle. Okay, so the size of 1 radian, right, is still an angle. So if we had an angle drawn in here, it would be 1 radian, and that's the angle formed by at the center of the arc formed by 1 radius, right? So if I took this radius and drew it here, the angle that it makes there is called a radian. Now that means that going around the whole circle, remembering that our circumference is equal to 2 pi times the radius, that going around the whole circle there would be 2 pi radians in a whole circle. And that also means that in a semicircle we'd have pi radians, semi being half. Okay, so a radian is just another way to measure an angle, and it's a more exact way of measuring an angle. So what that means for converting between radians and degrees is that if we're going from radians to degrees, we're just doing a ratio kind of deal. Okay, so in every pi radians there's 180 degrees. Okay, so to get from a certain number of radians to degrees, we're going to multiply it by 180 over pi. And then to get from degrees to radians, we're just going to do the opposite. We're going to times by pi over 180. Okay, so what you'll find is if you're converting from degrees to radians, 99% of the time you're going to end up with pi in your answer. And if you're converting from radians to degrees, once again, you'll probably end up with no pi in your answer. And that's because the pi in the denominator will cancel out the pi in the radians. All right, but not every time. We're going to have a look at that as well. So feel free to pause the video here to have a go at it by yourself. But we're just going to do some quick conversions here. So going from 135 degrees to radians, we're going to take 135 and we're going to times that by pi over 180. And then it's just a matter of simplifying from there. That's going to give us 135 pi over 180. And if we simplify that down, our highest common factor is 45. So if we simplify that on down, we're going to end up with 3 pi over 4. Now, going from radians to degrees, we're going to take 3 pi over 16 and we're going to times that by 180 over pi and see how we can automatically cross cancel those pi's there. Then you've got 3 times 180 being 540 over 16, and for degrees we tend to use decimals, so if you chuck this into your calculator, that's going to be equal to 33.75 degrees. Now, going from something like 143 degrees into radians, you'll probably see straight away that we don't really have a nice way of cancelling common factors out. In this case, your answer would just have to be 143 pi over 180. There's no way around that, okay? It would be really annoying to find on the unit circle, which we'll go through another time, but we cannot simplify that down further. Now, for this last one, it doesn't have a pi in it, but this is still radians, okay? Which means that in our final answer for degrees, we'll have a pi in the denominator, but once you use your calculator, you'll have your decimal places, okay? So going from 1.4 radians to degrees, we're still going to do the same thing. We're going to times it by 180 over pi. That's going to give me 252 over pi, which when we put that in the calculator, will give us 80.21 degrees.